All right, so this is the one, the network examination. You use Wireshark. It is by the best tool. Microsoft has something called Netmon they like, but everybody in the business uses Wireshark. It's by far the best tool. So here's some here's some data to examine. All right, so you just open it in Wireshark. You can install it on every operating system, and this will show you the packets. So in Wireshark, at the top, you see a summary of every packet. So you see here, it has the time, source and destination IP address, TCP, length, and over here you have a summary. So this is from port 50690 to 443. So this is connecting to HTTPS, which uses 443. This is a SYN, opening a connection. SYN ACK is the response from the server, and then ACK from the client. That's the three-way handshake that opens a TCP connection. It opens a socket so the two of those devices can communicate. Then here's some traffic to Dropbox, and so on. So there's a bunch of traffic here. So let's see what we're supposed to find here. This is going to be FTP. So, I should mention the other panes. This is the summary pane. Now, if you click on one of these packets, like this Dropbox packet, here you see a breakdown in the OSI model layers. This summarizes the bits in the packet at layer 1, which is just the physical signals that are transmitted through the radio. This is Ethernet, which goes by MAC addresses, like you see here. Here's Internet Protocol, which goes by IP addresses and is used to find the physical location of the device at the other end. Once you've found the physical location of the destination server, then you use a higher level protocol like TCP or UDP to speak to the specific process up there, and that goes by port numbers. And then inside here is the payload, something about Dropbox, sending some JavaScript in this packet. And here you have just the raw hexadecimal data in the packet, and viewed in ASCII too. And you very rarely use that. You can, but usually this is what you use, and you use this, and you also use higher level tools like following the TCP stream. Now, if you have, typically your network is like this, there's a bunch of different kinds of traffic on the same network. And so you want to filter it down to the stuff of interest, and what we care about here is FTP. So we're going to filter it for FTP. This is a display filter. You type FTP, it's going to be read until you reach a valid frame, a valid description like FTP. Then you press enter, and now it shows you only the FTP packets. There were 296 packets, but now I'm only looking at 39 of them, the FTP packets. And if you just look here, you can tell a lot just by reading this. Please log in with user and password. And here it sends username and password. And this was successful. So you don't even have to look anywhere but here if what you want to do is steal passwords and such. That's the problem with FTP. It sends passwords with no encryption, and Wireshark exposes them right there so you can easily see them. So you find John's password. Now we're going to find an HTTP password. So I download this stuff and run that. And I don't see anything because I still let the FTP filter in there. And this is not FTP. Now there are 92 packets here. So if I get rid of the filter, now I see a lot of different kinds of traffic. And the green is HTTP. And that's what I want to see. So I filter for HTTP. All right, and here we are. Now, this looks like basic authentication. Let me track my rules here. I have an HTTP password. It's going to be, it's in a post. Okay, this is a normal post login. All right, this is the simplest one. What you have get and post. Get you use to fetch a resource like an image off a web page. Post is what you use to send data up. And here it's posting something to a login page. So this packet probably sent up a name and password. And so you got Ethernet, Internet, and TCP, sending it up to port 80. Then you have Hypertext Transfer Protocol here, and you have the form here. And so the data that was sent in the form is here, and there it is, username and password. So that's unencrypted HTTP, which is very rare these days, sending data without encryption like FTP. It's still supported on the internet, but most people have learned not to do that. All right. Now, one thing that can help here is you can follow the stream. Instead of finding the one packet and examining it here, you can take any packet in the stream, right-click, follow, TCP stream, and now you'll see the data the way the user did, with all the addresses removed. So here's the post, sending up the data and having the username and password there. And down here is the reply, which has a status of 200, okay. And then down here, it has some compressed data you can't read. because it said content encoding gzip. So this might say you logged in correctly. It might say password rejected. You can't tell unless you unzip it. And Wireshark doesn't do that for you as far as I know. But anyway, that's one way to see packets more or less the way the users saw them, to follow the stream. And so now we're going to view the HTTP reply. According to this, we are. So I sent the, let's go back to just HTTP here. When you view a stream, it limits you to just that stream, although that's probably okay. Here's the login. Going up to the server, 129. Here's the server acknowledging it. And this looks like it sent something back. This is probably the data. And there's the compressed data. But I think Wireshark did unpack it for you. That's why I didn't know it to unpack gzip, but it does. So now you can see login denied. So I can tell that that was the wrong password. That's interesting. All right. And so you can go through these, and the easiest way to go through the several attempts is to follow the streams. So when you look at a stream here, let me follow that stream again. You can go to the next stream here. That's stream 2, here's stream 3, stream 4, stream 5. So you can try the different streams. The easiest way to look at different streams and try to find one where you actually got in. All right. And then there's basic authentication, which is an attempt to make this more secure. It's still pretty bad. So if I open the basic authentication packets and clear the filter, okay, here we are. Again, we can do HTTP, but here's how basic authentication works. You send a GET, and you get it 401 unauthorized. Then your browser will pop up a box asking for a name and password and send the same GET again, but this time with credentials, and then you get in. So if you look at this GET, the HTTP GET that was sent, HTTP is just several lines of text. So here it's sending, asking for stuff, and you see it has some accept lines, a user agent, an upgrade, a connection line, but no authorization line. So you're not authorized. The next time you send it, now it added this authorization line. And the authorization line, unfortunately, it ought to be encrypted, but it's not. It's just base64 encoded, which means you take all the bits and group them by 6 instead of 8 and turn them into this. So this is just can be easily converted back, and Wireshark does do that for you. So it's the username : password. So those are the credentials that were sent. And they were accepted because you got a 200 OK here. So that's how basic authentication works. And it is also not safe. However, you can do it over HTTPS, and then it's got another layer of encryption above it that's pretty strong, quite strong. So that would make it more secure. Now, the second part of this is all extra credit, and it gets pretty hard. But I set this up. I got this from Red Team Capture the Flag transmission. And so it's kind of fun. So you get this APT capture PCAP. And now, look at this. The first thing is you want to find protocols used for encrypted communication. And so you use statistics protocol hierarchy. And this will show you the various protocols that have been used here. And you find out, I'm not seeing the right kind of data here to tell which one is encrypted. Let me see what I've done wrong here. There's only one protocol used for encrypted communication with more than 3 packets sent. Statistics protocol hierarchy. Did I do the right thing? It just, you don't see anything here about encrypted packets. I wonder if it's, I don't, it is APT capture. No, it's the right data. I think that should be statistics. I'm a little confused why I don't see IP, TCP. You can't tell if any of this is encrypted from this. That view is not showing me what I want to see. Let's try statistic conversations. Yeah, Well, I'm a little confused about why you don't see it. You're supposed to be able to see the protocols, like there's supposed to be SSH in here, for example. And there is. And that's an encrypted protocol. And there's also supposed to be TLS. So we should see those. Now, somehow I'm not seeing them here, and I wonder if there's some kind of... I wonder if there are different versions of Wireshark involved, because this is just showing me useless stuff. Oh, there's SSH, but it doesn't show me TLS. It only shows me one packet of each one, so this seems very messed up. You're supposed to see TLS and SSH, and for some reason I'm not seeing them here. Maybe maybe I need to update my version of Wireshark or something. Let me stop this recording.